Hello everybody. Got a fairly complicated derivative for us today. We have a composition of functions here. Inside the composition of functions is a product of functions, and within that product of functions is another composition of functions. So in order to find this derivative, we are going to need to start with a chain rule, move to a product rule, and finally to one more chain rule. So this is a fairly complicated process. Let's go ahead and start it. So we're going to find first the outside function is the natural log of something. Inside function is x squared e to the 4x. So alright, we're ready to set up our chain rule. Chain rule says the derivative is going to be the derivative of the outside function. So the derivative of natural log of something is 1 over something. So it's derivative of the outside function. We leave the inside function alone. And this is times the derivative of the inside function. Well, the derivative of this inside function requires a product rule. And in the product rule, also remember that there's this extra chain rule waiting for us. So let's get started. We'll do the product rule here to find the derivative of the inside in this chain rule. And the product rule says you take the first function, x squared, times the derivative of the second. Here's where we need that chain rule. The derivative of e to the 4x is e to the 4x times 4. So there's the chain rule right there. So it's first times derivative of second plus the second function, e to the 4x, times the derivative of the first. And the derivative of x squared is 2x. So there we go. This is going to be our derivative. We just did a chain rule first. We did a product rule afterwards to find the derivative of the inside. And within that product rule, we did yet one more chain rule. So let's go ahead and simplify this because it looks like we've got quite a bit of cancellation happening here. If we distribute this x squared, or this 1 over x squared e to the 4x into both of these terms here, the first fraction is going to turn into a 4 times x squared times e to the 4x all over x squared e to the 4x. You'll notice I did reorder these three factors in the numerator here. The second term here is going to be 2 times x times e to the 4x all over x squared e to the 4x. And I also took the liberty of rearranging these terms here. So okay, we've got a lot of cancellation that's going to happen here. The x squared goes. The e to the 4x goes. The x cancels with one of the x's in the denominator in this second term. This e to the 4x goes. So what we're left with is just a 4 in this term and a 2 over x in the other term. And this is as simple as we'll be able to get it. So this is a fairly complicated problem. What with the chain rule followed by a product followed by another chain and then the simplification afterwards, this is quite an involved thing. Something you should always pay attention to when you are doing problems like this is there may be an easier way. So when you're looking at this, you may remember back from your pre-calculus days that when you were dealing with natural logs have certain properties. And you're allowed to split this multiplication and to bring exponents down. So instead of dealing with a function in this form, which requires 3 separate derivative rules to get done, we can instead write this as 2 times the natural log of x. And remember that natural log and e are inverses of each other, so this is just plus 4x. Now I just expanded this out all at once. If you have questions about how I did it, you should definitely ask me. But if you feel comfortable with those natural log properties, you'll be able to expand this out in this way. And this is a much, much easier derivative. So let's go ahead and do it. The derivative in this case, the derivative of 2 times natural log of x is 2 over x. The derivative of 4x is 4. We have avoided every complicated derivative rule that we could. And this problem is very, very simple afterwards. So moral of the story, it is entirely possible to do multiple derivative rules one after the other, and the cancellation is not an impossible task. But if you can help it, you should stop before you start a problem that looks very complicated, and you should see if you can come up with any way to simplify it. It may really be worth your time. Anyway, if you have questions on this or anything else, please talk to me in my office or ask questions in class. I'm happy to help. And as always, happy mathing.